Hello students, welcome to this theory session of Is Matter Around Us Pure? In this session we are going to discuss about the separation of constituents from a homogeneous mixture and also the separation of two immiscible liquids, the method used for the separation of two immiscible liquids. In the previous session, we have discussed about the sedimentation, about decantation, about filtration, about centrifugation, right? Now let's see how the mixture of oil and water can be separated. How the mixture of or how a homogeneous mixture can be separated. Let's start our session, students. Before starting this, if I am asking you a question, how will you separate the mixture of camphor and sodium chloride or salt? What will be your answer? It will be sublimation. See, camphor direct undergoes sublimation whereas sodium chloride does not. Likewise, ammonium chloride and sodium chloride. Ammonium chloride undergoes sublimation whereas sodium chloride does not. Right? Then let's see the separation of two immiscible liquids. See, oil is insoluble in water. Oil and water form separate layers when placed together. So these are known as immiscible liquids. Mixture of oil and water is heterogeneous. How? The oil forms a separate layer. This is oil and the below one is water. The mixture of oil and water is heterogeneous and can be separated by a separating funnel. If I have to separate a mixture of mustard oil and water, which is lighter, oil is lighter, so it will form the upper layer. Whereas water being heavier will form the lower layer. Likewise, a mixture of carbon tetrachloride and water, the carbon tetrachloride will form the lower layer and water will form the upper layer. So the two immiscible liquids like this mustard oil and water, carbon tetrachloride and water, they can be separated by using the separating funnel. I'll show you how it looks. This is a separating funnel. So in this case, oil and water. They too form different layers. Oil being lighter, it forms the upper layer, and water being heavier forms the lower layer. Water can be collected from this separating funnel. Likewise, if it's a solution of carbon tetrachloride in water, water will form the upper layer, carbon tetrachloride will form the lower layer. For separating two immiscible liquids, what is used is a separating funnel. Understood this? Let's take up another method of separation. We have seen the separation of components of heterogeneous mixture in solutions. Right? In case of say suspension, solution, colloidal solution, likewise. Can we have the heterogeneous mixture of solids? Heterogeneous mixture of solids is say ammonium chloride and sodium chloride. But there, if I'm taking ammonium chloride and sodium chloride, mixture, NaCl, their particle size are not different. But they have one property in which is different, that is sublimation. Ammonium chloride undergoes sublimation, whereas sodium chloride does not. We can use this property of sublimation here. But there are heterogeneous mixtures of solids where different sizes of particles are present. The particles can be separated on the basis of their size. So this is a heterogeneous mixture. The sizes are different. The shapes are different. How can they be separated? Just by hand picking. I can just pick up the things which are looking similar for separating the mixture. For separating a heterogeneous mixture of solids, what can be done is one is sublimation If at all one of the solid undergoes sublimation, other is hand picking, if I can pick it, and one more method is there, that is sieving. Sieve you must have seen. See, in order to separate sand from pebbles, what is used is a sieve with a broader pores. In order to separate tea leaves from tea, what is used is sieve. That is, it is easy to separate the heterogeneous mixture consisting of two crystalline solid constituents. Why? Because the crystals differ in their shape and size. So they can be easily separated by hand picking or using sieve. For example, a mixture of potash alum and niter. Crystals of potash alum are octahedral in shape, while those of niter, that is potassium nitrate, are needle-like in shape. Separation is very simple, by hand picking, or we can use a forceps also. If the constituents of mixture, they differ in their shapes and sizes, they can be separated by just hand picking. If the size is very small, they can be separated by sieve of specific size. So wheat grains can be separated from husk by using sieve of specific size. Or they can be separated by winnowing and all those things which you have started. Winnowing also. We can separate tea leaves from tea by using a sieve. This is all about the separation of constituents of heterogeneous mixture. Basically, this process, the methods are employed on the fact that they depend on the properties of the mixture, whether they are magnetic or one of the constituent is volatile. One of the constituent, in case of solids I am saying, undergoes sublimation. There is difference in their densities, right? So the properties of the constituent should be different. One of the constituents should be magnetic or volatile or should undergo sublimation, or their density should be different, or the shape in case of solids should be different, or size in case of solids should be different. These are all what? These are all the physical properties. Constituents of heterogeneous mixtures can be easily separated based on this, and the method which is applied depends upon these factors. Right? Now let's discuss how can we separate the constituents of a homogeneous mixture. Separation of constituents from homogeneous mixture. What are homogeneous mixtures? The mixtures in which composition is uniform and the components of mixture are present in single phase. Right? Every part of the mixture has got the similar property. This we have already discussed, that every part of the mixture has got a uniform composition, the similar properties, and also the constituents present in a homogeneous mixture cannot be identified. Say seawater. Seawater consists of large amount of salts like potassium chloride is there, magnesium chloride is dissolved in it, sodium chloride is dissolved in it. But can you see potassium chloride in seawater? No. Can you see magnesium chloride in seawater? No. Also sodium chloride. We can't see sodium chloride, potassium chloride, magnesium chloride in seawater. Seawater is a homogeneous mixture. The properties are also uniform throughout. How can we separate these salts from seawater? The separation basically depends upon the differences in the properties. In case of heterogeneous mixtures, the components can be easily identified. But in case of homogeneous, these cannot be identified. They should have some difference in their properties. Say this, if I am taking seawater into consideration, Seawater is a mixture of water plus these salts, that is potassium chloride, magnesium chloride, sodium chloride, some bromides are also present, even iodide is present, right? How can water be separated from these salts? It's a very simple thing. On boiling, see, water changes into its vapor state. These are all non-volatile, right? These constituents or these components from the mixture can be separated by boiling. But we can't do simple boiling. For this, distillation is done. Now, what is distillation and where it is done? I'll tell you. What we have to do is, if I want to collect this water for drinking purpose, for any other purpose, for industrial purpose, distilled water is not used for drinking. Remember that. You should never use distilled water for drinking. It is used in industries because it is free of minerals. So we should not use distilled water for drinking. Distillation is done. There I want to collect this water and use for industrial purpose. How this is done? So this is how distillation is done. What is taken? This is a distillation flask. It is a small one. If large amount of water is to be obtained, this size will be also big. It is heated. This is a thermometer. Right? The spelling over is wrong. It's thermometer. Thermometer. This is thermometer. There is a thermometer which is used for setting up the temperature. Say water boils at 100 degrees centigrade. So the temperature will be set at 100. The vapors are formed. It is passed through the condenser. The liquid water is all the time flown through the condenser. Say this is cool water is in, it flows through the condenser tube, right? And the water which becomes hot, it comes out. This center one is the condenser tube. The water vapor passes through this condenser tube and is collected in the receiving flask. This is how distillation is done. Now whatever non-volatile impurities are there, like different salts are there, they are left behind. This water which is obtained, it is free of any sort of ions, right? Because say the metal ions are present over there, the impurities are of potassium chloride, which is non-volatile, sodium chloride, which is also non-volatile, which doesn't change into its vapor state, magnesium chloride, which will also not change into vapor state. If it's sodium bromide, it will also not change into vapor state. If it's sodium iodide, it will also not change into its vapor state. So what will change into its vapor state is water. Water forms water vapors, and vapors are passed through the condenser and they are collected in a flask. This condenser is kept cool with the water. This water is flown in this tube. Right? So this is what is distillation. We can separate the non-volatile components from the volatile substance of a mixture. Right? This process is simple distillation. It's the distillation of a mixture which contains one non-volatile component and other is the volatile component. But what if there are two volatile components? What if there are three volatile components? There are mixtures, say acetone and water, both are volatile. Then how the separation will be done? Likewise, crude oil, which is obtained, from which the petroleum, diesel, coal tar and the chemicals are obtained. And that all these substances are volatile. How they can be separated? They are separated by fractional distillation. I'll show you how it is done. See, separation of constituents from miscible liquid mixture. Separation is based upon the difference in boiling points of the constituents. right? Both are, say if there are two liquids, say suppose there is acetone and water, both are liquids, right? They are miscible also. They are forming homogeneous mixture. They both are volatile also. But the difference lies in their boiling point. So this fact can be utilized. The boiling point temperature of acetone is 56 degrees centigrade, that is 319 Kelvin, while that of water is 100 degrees centigrade, so 373 Kelvin. It is, say, 56 plus 273 will give what? 319 Kelvin. The separation can be done in a distillation flask. This is how fractional distillation is done. That is, at 319 Kelvin, the vapors of acetone will be collected, and at 373 Kelvin, the vapors of water will be collected. In that fractional distillation thing, different temperatures are maintained at different levels. Right? So the liquid mixture is taken in a distillation flask and heated. The boiling point of acetone is 56 degree, which is less than water. So it will change into vapors which will rise upwards. They will get condensed and on passing through the condenser and collect in a receiver. At this temperature, water will not boil and remain in the flask. And this is how we can separate. There are two mixtures. There are two things over there. That is water and acetone only. So the temperature is raised till 319 Kelvin only, so that all the acetone present is converted into its vapor state. At this state, will water convert into the vapor state? No. Because the temperature of the distillation flask, or the temperature which is maintained, is 319 Kelvin. But water boils at 373 Kelvin, which is a bit higher one. The temperature of 319 Kelvin is maintained in the distillation flask, so that the vapors of acetone are obtained in a receiver or obtained in another flask, which can be passed through a condenser and acetone can be collected. Right? See, this is a diagram of fractional distillation of crude oil. From here, crude oil is subjected, or it is poured in. Right? This is the inlet. At different levels, different temperatures are maintained. Right? Say at the bottom there is 600 degrees Celsius, then it's 270 degrees Celsius, then it's 170, then 120, then 70, and then 20. And how? Fractions decreasing in density and boiling point. Up, what all fractions go? Which have less boiling point and which have less density. So the fraction which is obtained at 20 degrees centigrade is C1 to C4 gases. That is, these are the liquefied petroleum gas. This is a fraction which is obtained by fractional distillation of crude oil. Fractional distillation is nothing. Distillation, you know, it is just heating the solution or to its boiling point. So I can say that it is boiling the solution, and the components present in it have different boiling points. Say the one which is, say, butane, it is C1 to C4 gases, that is liquefied petroleum gas. It has a boiling point of 20 degrees Celsius only. In this fractional distillation thing, the distillation flask, what is done is at different levels, different temperatures are maintained. Now at 20 degrees centigrade, what is obtained is liquefied petroleum gas. At 70 degrees centigrade, the chemicals are obtained. At 120 degrees centigrade, petrol is obtained, that is gasoline. At 170 degrees centigrade, its jet fuel is obtained. Right? And at 270 degrees centigrade, the diesel is obtained. At the higher temperatures, lubricating oil is obtained. At 600 degrees centigrade, the fuel oil for ships and factories is obtained. And at still higher temperature, whatever is left is used for the residual thing. Whatever is left is used for making coal tar, that is used for making roads. This is what is fractional distillation. This is just to show you the fractional distillation. You don't need to remember the fractions, the values of the carbon chain, the things which are obtained. It is just to show you how the components of crude oil are separated, or how the components are separated when all are volatile. So they are separated depending on the differences in their boiling points. Right? Say air. Air is a mixture of gases. How can these gases be separated? Let's see. Separation of gases from air. Air is a homogeneous mixture of number of gases like nitrogen, oxygen, inert gases, carbon dioxide, water vapor, and methane, and many other gases. Sulfur dioxide is also there in polluted air. How can they be separated? By fractional distillation. Right? Now, how this can be subjected for fractional distillation? First of all, in fractional distillation, what happens? It's just the boiling of a liquid so that it can convert to its vapor state. That vapor obtained is condensed and it is separated. So first of all, what you'll have to do is, or what has to be done is, liquefied air should be converted to the air should be liquefied. How air is liquefied? Air is a gas. Air is a mixture of gas. It should be liquefied. A gas can be liquefied by increasing pressure and decreasing temperature. A gas can be liquefied by increasing the pressure and decreasing the temperature. After that, we have obtained air in the form of liquid, and then it is subjected to fractional distillation. What will happen? The gas with a lesser boiling point will be distilled out first. That is the boiling points of the main gases, that is nitrogen and oxygen. Boiling point of nitrogen is 196 degrees centigrades and it is minus 182 degrees centigrades respectively. Right? The one with a lesser temperature will be obtained first, and the one with a higher temperature will be obtained later. In this case, which will be obtained first? Nitrogen, and then oxygen. Right? Now, when nitrogen and oxygen separated, air, the pressure is increased and temperature is decreased. After that, what we will be getting is the liquefied air. Liquefied air is subjected to fractional distillation. The low boiling nitrogen will be separated out first. The low boiling nitrogen will be separated out first, and the higher boiling oxygen. Remember this one thing very clearly, that in the fractional distillation of liquefied air, the component which is first obtained is nitrogen and afterwards it's oxygen. I'm telling you about nitrogen and oxygen because these are the main components of air. Right? I hope you have understood this. There is one more technique, students, that is chromatography. Let's discuss about chromatography now. Do you know what is chromatography? It is used for separation of constituents from a mixture. We are doing separation only, so it is used for separation. In Greek, the word chroma means color. And the word chromatography implies writing in color. This technique was initially used to separate colored components from pigments and dyes. This chromatography helps in separating and identifying the components present in homogeneous mixtures, which may be available even in very small amounts. Say if I am taking a mixture of blue and black dye, a mixture of blue and black dye. Now these components are present in very, very small amounts. They are miscible also. They are not volatile. How can we separate them? That is separated by chromatography. Let's see how it is done. See, this is a chamber where paper chromatography is done. Paper chromatography is very, very important. There are a number of chromatographic techniques available, that is gas chromatography, HPLC is also there, thin layer chromatography is also there, but of them, paper chromatography is very important and is of wide application. See, what is done is, this is a solvent taken over here. Any solvent can be taken, say water also can be taken. This is the filter paper, right? And in the filter paper, at the center, a mark is put. Say if I'm putting a mark over here, or if I'm putting a mark over here. At this mark, some dye is added. Whatever I want to separate. If I want to separate the pigments of chlorophyll, I can put a drop of chlorophyll here. If I want to separate blue-black dye, I'll put a dye here. Put a drop of dye here with the help of a capillary tube. Right? And just hang it in the chromatographic chamber, and it takes, say, long time, so 6 to 8 hours. It may take 3 to 4 hours also. It may take 6 to 8 hours also. No, I'm so sorry. It can be done within an hour or two. And also it depends upon the mobility of the solvent which is taken. See what happens, in the filter paper, there are pores. You must be knowing this. Right? Now, do you know what is capillary action? Through these pores, see, the water is there. Water is taken in the chamber. What happens? The water molecule rise up through capillary action. I hope you know capillary action. The water molecules rise up. Together with the water molecules, the dye molecules, whatever are present, they will also move up. Right? Now, these molecules, they have got different mobility. Obviously, these molecules, they have got different molecular weights. The one which is lighter will have faster mobility or will move faster. The lighter will move faster. And the heavier will move slower. So the particles or the components which are present in the dye, they'll move depending upon their molecular weights. And they move with water molecules. These water molecules rise up by capillary action. With the water molecules, the dye molecules, they also move. So this is a chromatogram of chlorophyll. Different pigments are there and they move to different heights. This is actually the chromatographic chamber. This is the chromatogram. See, this has moved till here only. This red one has moved till here. Likewise. So we have separated all the pigments. Right? So chromatography is a technique which can be used for separation of components from a miscible solution or from 2 or 3 miscible liquids. Separation of components which are miscible, right? And which are also present in very, very small amounts, right? They have got differences in their mobility. The one which has got less molecular weight will move faster and the one which is heavier will move slow. So we can separate the components of miscible liquids by chromatography also, right? So these are all the techniques used or methods used for separation of constituents of mixture. I hope you have understood these techniques. They are nothing, they just depend upon the physical properties of the constituents. Now, you don't just think that you'll be getting straight questions like explain chromatography, explain sedimentation, decantation. No. You'll be provided with questions. I'll just show you an example. See, the question is, how will you separate the constituents present in the following mixtures? common salt and water. How will you separate? Water is volatile, common salt is non-volatile. We can do simple distillation, right? Iodine and sand. Iodine undergoes sublimation, sand doesn't undergo sublimation. So we can separate. Kerosene and water. Kerosene and water are insoluble and they have got different densities also. They are not miscible. They've got different densities also. So they can be separated by separating funnel. Sugar and sulfur. Sulfur dissolves in carbon disulfide and this can be obtained. Say sulfur can be obtained by evaporation and sugar remains as such. So sugar can be separated from the solution by filtration. That is, both sugar and sulfur, they are dissolved in carbon dioxide in a beaker by stirring it with a glass rod. Sulfur dissolves while sugar remains as such. On filtering, sugar separates as a residue. The filter upon concentration and cooling gives sulfur. So this is a pattern of question which can be asked or which is asked from this topic, right? So we have completed the chapter, completed this topic. His matter around is pure. I hope you have enjoyed these sessions. I hope you have understood the concepts. And I thank you for listening patiently and for listening all these sessions. Thank you, students, for being with me, for your patience. Thank you and do have a nice time ahead.